Every major galaxy in the universe rotates around an unseen anchor, a gravitational well massive enough to hold billions of star systems in a cohesive stin. To measure the weight of these objects, astrophysicists use a standard unit of cosmic industrial storage, the solar mass. One solar mass is exactly the weight of our own sun. For our local baseline, we look to the center of the Milky Way, to the supermassive black hole known as Sagittarius A star. This glowing ring of light is the first direct image of Sagittarius A star. It represents an object packing roughly 4 million solar massives into a single, dense point in space. For decades, the math suggested that structures on this scale, millions of times heavier than a star, represented the absolute upper limit of black hole formation. But observations of distant regions of the cosmos have revealed objects with gravitational boundaries that dwarf those early calculations by orders of magnitude. Compared to these distant anomalies, a 4 million solar mass object like Sagittarius A star is essentially a statistical rounding error. To find the true bounds of astrophysical structures, we have to look much further back into the deep history of the universe. Our local supermassive black hole feels enormous to us, but it is microscopically small when mapped against the extreme limits of cosmic architecture. 18 billion light-years away sits an object known as TON 618. It belongs to a classification reserved strictly for the extreme end of the mass spectrum, the ultramassive black hole. These objects are measured in tens of billions of solar masses. The primary data point for TON 618 places it at approximately 66 billion solar masses. To understand this scale, we map our solar neighborhood. Replacing the Sun with TON 618, a dark sphere instantly consumes the inner planets. Expanding outward, it swallows Jupiter and the gas giants. Ultimately, our entire solar system is a microscopic speck in this void. This volume represents an absolute gap in space, generated by an extreme concentration of mass. TON 618 represents a gravitational architecture so vast that it breaks our intuitive models of physical volume. The black sphere in these models is a mathematical boundary rather than a physical surface. Astrophysicists call this boundary the Schwarzschild Radius. It marks the exact physical distance from the central singularity to the event horizon, the point where the escape velocity exceeds the speed of light. To measure distances on this scale, we use the astronomical unit, or AU. 1 AU is the distance from the Earth to the Sun, roughly 93 million miles. A line plotted from the absolute center of TON 618's gravitational well towards its edge maps its true internal geometry. Escaping this void requires crossing hundreds of AU, distances that dwarf the orbital path of any known planet. As the line reaches the edge of the event horizon, the counter locks. The radius of TON 618 is 1,300 astronomical units. Doubling that radius reveals the total width of the event horizon, a diameter of 2,600 AU. Within a massive geometry this size, standard spatial physics are stretched to their absolute breaking point. A 1,300 AU Schwarzschild radius serves as a spatial boundary, redefining the limits of astrophysical geometry. To truly test the scale of this volume, we have to measure it against the absolute speed limit of the universe, the speed of light. We can apply that constant velocity to the 2,600 AU diameter of TON 618. Imagine a single photon attempting to travel from the center toward the edge of the event horizon. The extreme curvature of space forces the photon's velocity to appear to decay. It lacks energy to reach the edge, and the void pulls it back. Crossing a void of this enormous size at the speed of light would require over a week of continuous travel. By comparison, light bridges the gap between the Sun and Earth in just 8 minutes. An object of this scale effectively traps both time and light, forcing them into a multi-day journey across a landscape of pure nothingness. The physical dimensions of TON 618 present one problem, but its origin presents a more difficult mechanical mystery. Under the standard astrophysical model, black holes are born from the collapse of massive, dying stars. Because stars have a strict upper mass limit, Black holes forged by stellar death begin their lives as relatively small gravitational seeds. These small seeds rely on accretion, feeding on surrounding gas and dust over billions of years to grow. This chart illustrates the accretion limit. A black hole has a maximum feeding speed. Even at this maximum rate, the universe's age provides insufficient time for a stellar seed to reach 66 billion solar masses. Standard stellar death physics cannot mathematically account for ultramassive architecture. TON 618 stands as evidence that the standard model of black hole formation breaks down at these extreme cosmic scales. Since it lacked the time to grow from a small seed, this object must have been born massive. The extreme conditions of the early universe were defined by vast, uncontaminated clouds of primordial hydrogen. This suggests a mechanism known as direct collapse, where immense clouds of gas succumb to gravity while entirely bypassing the process of star formation. An immense cloud containing thousands of light-years of primordial gas begins to rapidly collapse under its own crushing weight. This primordial material is rapidly compressed into a massive, silent black void, skipping the traditional supernova phase entirely. This direct collapse creates an instant monster seed, capable of scaling into an ultramassive black hole within the timeframe of the universe. TON 618 is the raw, unburned fabric of the early universe, forged directly into the